Any homework questions at all? You guys have any questions from the homework at all? Yes, no? Okay, I assume homework is going okay. Okay, so last time we ended up with the following. So last time we justified the two limits. The limit as theta goes to 0 of sine theta divided by theta is 1. Notice that this is equivalent to saying that the limit as theta goes to 0 of theta over sine theta, that is 1 as well. If a ratio goes to 1, right, then the reciprocal should also go to 1, right? Okay. So number 2, the limit as theta goes to 0 of cosine theta minus 1 over theta, and we showed that this was 0. Number 1, sometimes in applications, I have seen at least at one place when I took a physics course long time ago, in optics, if you take a course in optics in physics, at least there, I'm pretty sure it is being used in many other places, but they use a approximation of sine theta when theta is small. So when theta is so number 1, you can interpret that as when theta is close to 0, negative or positive. When theta is close to 0, the value of sine theta is about the same as theta. Okay? So number 1 basically implies that sine theta is close to theta when theta is close to 0. So the value of sine of theta is about the same as the angle theta. Is that making sense? All right. So today what we want to see is how we could use this two limits in order to compute the derivatives of the trig functions. But before I do that, I want to do some examples to make sure you understand these limits, especially number 1. You only have to remember number 1, okay? You don't have to remember the limit in number 2. So what is let's say, what's the limit as x goes to 0 sine of 7x over 4x. So we want to compute that limit. And the question is, how do we do that? How do we compute this limit? I want to apply limit number 1. The limit number 1 is that the limit of sine theta over theta is 1 as theta goes to 0. So how do I apply it here? How do we apply it here? If I want to apply that, what's the angle here? The angle here is 7x, right? And if I had 7x in the denominator, then I could have said that the limit is 1. So remember, you have sine theta divided by theta. So the angle where you are evaluating sine must be the same as the denominator. So if I had 7x here, I could have said that the limit is 1. But I don't have 7x. So how would I compute this limit? Anyone? How would you go about computing this limit? Right? Well, as we said, you need 7x in the denominator, right? You need 7x in the denominator. However, you didn't have 7x, right? I had 4x. I changed the 4 by 7. And how do I adjust to make sure that I didn't change the quantity? I should multiply by? Yeah, 7/4. You see, if I multiply by 7/4, notice that I didn't change the quantity. Okay? However, writing it in this way makes it possible to use limit number 1. Now I could say that the limit of this guy is a 1. Okay, so what's the limit of the whole thing? 7/4. Is everybody okay with that? Okay, let's look at another example. Let's take the limit as x goes to 0 of x times cotangent of x. And so what is that limit? Let's investigate what's happening here. What's the limit of the first factor x when x goes to 0? 0. When x goes to 0, the first factor is x, so it goes to 0. So the first factor here, this guy, goes to 0. How about the second factor? This guy goes where? When as x goes to 0, what's the limit of cotangent of x? Yeah, remember cotangent of x is cosine x over sine x, right? And as x goes to 0, cosine x goes to what? 1. This guy would go to 1, and this guy goes to what? 0, right? So what's the limit of the ratio? Is plus or minus infinity? Okay, we don't have to be precise on whether it's plus or minus, but it's going to be plus or minus infinity, like this. Okay? In fact, it is going to be, if x goes to 0 from the right, it's going to be positive infinity. If x goes to 0 from the left, it's going to be negative infinity. But my point is, okay, I know the limit of the first factor, I know the limit of the second factor. Looking at those limits, it doesn't tell me what the limit is. The limit is not necessarily 0 because you're multiplying with 0. Am I making sense? You're not really multiplying 0 and infinity. You cannot multiply 0 and infinity, right? Why? Well, infinity is not a number. We're just saying that the value of that function becomes big as x goes to 0, right? So, for example, if I have the function, if I'm taking the limit as x goes to 0 of x times 1 over x, right? Notice that the first factor has limit 0 and the second factor has limit plus or minus infinity, right? What's the limit in this case? 1, because x times 1 over x is actually just 1. So the limit here is 1. However, the individual limits were 0 and plus or minus infinity. Okay? Again, my point is, by looking at these limits, by looking at the limit of the factors, we cannot come up with the limit of the function, of the product. So in this case, what should I do? Well, the key is we have to go back to that number 1. The limit of sine theta over theta is 1. That's what we have to use again. Now, if I want to use that here, what should I do? What should I do if I want to use that? Anyone? What should I do if I want to use that, a limit? If I want to use the limit of sine theta over theta is 1, what should I do here? Well, I don't have sine here, right? But can I bring in sine? Yeah, I can bring in sine by writing cotangent as cosine x over sine x. So then I can rewrite this. I can rewrite this as the limit as x goes to 0, x over sine x multiplied with cosine x. You guys agree with that? And now what can I say about the limit of x over sine x? The limit of x over sine x is 1. The limit of cosine x is, cosine of 0 is what? 1. So this is 1, and together then the limit is 1. Is everybody okay with that? So in your homework you have to compute these types of limits, and usually you have to use limit number 1 that I gave you. Okay, here's another example. Let's say I have the limit as theta goes to 0, sine theta divided by theta minus tangent of theta. And this is in fact one of your homework exercise. What's the limit? How would I compute the limit in this case? How would I compute the limit in this case? Again, let me give you the hint. The hint is we're going to have to use that limit number 1. The limit of sine theta over theta is 1. So how do I use that here? What should I do? Anyone? What can I do here so that I can use the limit of sine theta over theta? That's invalid. Let me. If I have 1 plus 2 over 3, right? I can write it as 1/3 plus 2/3. But if I have 3 over 1 plus 2, right? I cannot write it as 3 over 1 plus 3 over 2. Am I making sense? Okay. Yeah. You could, but yeah, I'm not sure if that's going to help. Yeah. Split up. Oh, right, tangent as sine over cosine. Yeah. So, in fact, I won't do that. What I'm going to do first, I'm going to do that in a bit, but I want to use sine theta over theta, right? So what I'm going to do is factor out a theta now, and I'm going to write it as 1 minus tangent of theta over theta. So that way I have sine theta over theta already. So let's rewrite this. I have the limit as theta goes to 0, sine theta over sine theta over theta times 1 over 1 minus tangent theta over theta. You agree with that? Okay. And now I'm going to change tangent with sine over cosine. So the limit theta goes to 0, sine theta over theta times 1 minus tangent of theta is the same as sine theta divided by cosine theta, right? So I have a theta already in the denominator, so I get this. You agree with that? Tangent is sine over cosine. And I think what you said, I could have replaced tangent by sine over cosine first and do what you said, but at the end I have to again factor out theta. So I simply did the opposite. Okay, so this is the limit as theta goes to 0, sine theta over theta, and I am going to write this as 1 minus sine theta over theta times 1 over cosine theta. Okay, you agree with that? Now let's see what are the limits. What's the limit of this guy? Limit of this guy is 1. What's the limit of this guy? 1. What's the limit of this guy? Cosine of 0 is 1. So this would be 1. So at the end, the limit would be 1 times 1 over 1 minus, hey, was it minus or a plus? I should have a plus here, sorry. Okay. And this will be 1 times 1, right? So what's the limit? What's the limit then? 1/2. Is everybody okay? Okay, so you're going to see similar limit problems in your homework. Did you need a few minutes to write it down? Okay, so now what we want to do is the main point of looking at those limits here was that we're going to use that to compute the derivatives of the trig functions. So first of all, let's see how we can compute the derivative of sine. So let's take f of x to be the function sine x. And so then what's the derivative? What's the derivative of this function? By the limit definition, we know that it is the limit as h goes to 0, f of x plus h minus f of x divided by h, right? Well, we just have to plug in then. What is f of x plus h? Well, f is sine, right? So it would be sine of x plus h. And what is f of x? Sine of x divided by h. Okay, if I plug in h equals to 0, what do I get? 0 over 0, right? If I plug in 0 for h, the numerator would be 0, the denominator would be 0, right? So it's not telling me what the limit is. But what should I do? How should I go about computing this limit? Previously, when we obtained 0 over 0 with rational functions, we factored out and cancelled out some factors, right? We tried to get rid of the factor that's giving us 0 in the denominator. But here, you cannot get rid of h that way. What you need to do is basically you have to be able to use limit number 1 that I gave at the beginning. So how should I proceed here? What would you suggest? Well, one thing for sure is I don't have I don't have a good intuition of how to proceed from this point. But usually in trigonometry, if you have no clue how to proceed, what should you try? Well, you should try to see if you can apply some trig identities, right? When you took your trig course, right, most of the time, what did you do? You applied trig identities, right, in most of the problems. So here, what trig identity can I apply? What trig identity can I apply? Well, remember, there is a sum formula for sine of A plus B is what? Sine of A plus B is sine A cosine B plus cosine A sine B, right? So this sine of x plus h should be what? Sine x cosine h plus cosine x sine h minus sine x divided by h. Okay, so that's what I have. Do I still have an... Well, it seems like I made the numerator more complicated looking, right? At least I have... Before I had 2 terms, now I have 3 terms. In that sense, maybe I made it more complicated, but it's going to work out in a bit. At this point, again, I really don't have much intuition what to do, how to proceed. I don't know how it's going to play out. However, you always try to see if there is any type of algebra that you could do. Yeah. We will break it up in a second, but before I break it up, in the numerator, we have to do some algebra. You see, if you look at these 2 terms here, right, you see that sine of x is a common factor. And what you have to do is factor that out. So I am going to, first of all, write the middle term first, cosine x sine h divided, that's what I'm going to write first. And then from the 2 far terms, these 2 terms, I'm going to factor out sine. So if I factor out sine, what do I get? I get cosine h minus what? 1. And the whole thing divided by h. Okay, now I'm going to use your suggestion, break it up into 2 fractions. So break it up as cosine x sine h divided by h plus sine x cosine h minus 1 divided by h. Okay, and well, now we should start smiling, because we can see that that number 1 limit and number 2 limit that I gave you at the beginning of the class, we can apply them here, because if you look at each term, what do we have? We have cosine of x, and then we have sine h over h, right? And the second term would be sine x times cosine h minus 1 over h. You agree with that? Okay, now notice that cosine x does not depend on h, right? X doesn't depend on h. So what's the limit of cosine of x as h goes to 0? Well, it is cosine of x. What's the limit of sine x as h goes to 0? It's sine x. But what's the limit of this guy? What's the limit of this guy? 1. What's the limit of this guy? 0. So what do I have then? All I have left here is cosine of x, right? So what we have found is that the derivative with respect to x of sine x is cosine x. Okay, so that's the formula number 1 that you have to memorize. Number 2, I am not going to compute the derivative, but you can compute it in a similar way. What's the derivative with respect to x of cosine x? It is negative sine x. Again, you could compute that by using the limit definition again. So instead of applying the formula for sine of a plus b, you're going to apply the formula for cosine of a plus b. What is cosine of a plus b? Cosine a cosine b minus sine a sine b, right? If you use that, you'll see that you're going to come up with this negative sine x. Okay. How about the derivative of now the other trig functions, right? So how would you compute the derivative of, what's the derivative of, let's say, cosecant of x? Well, how can I compute that? Well, because cosecant is what? Yeah, cosecant is, now I don't have to use the limit definition anymore. I can just apply quotient rule or the chain rule to come up with this derivative. So this would be 1 over sine. How can I come up with the derivative now? I can apply the quotient rule. But instead of using the quotient rule, what I'm going to do is, because we have already talked about the chain rule, I am going to say that this is the function sine x to the exponent what? Negative 1. So how do I find the derivative now? Well, you look at sine x to the negative 1, you wish sine x was just x, right? So assuming that sine x is just x, you can find the derivative by using the power rule. So by the power rule, it is negative 1 times sine x to the negative what? 2, multiplied by the derivative of the quantity that you wished was x, which is sine x. And we already know that the derivative of sine is cosine x. However, we are not done yet. This is the derivative, of course, but usually we write it in a nicer way. So this would be the same as negative cosine x divided by sine squared x, right? And then even this expression isn't that nice, so we are going to rewrite this in the following way. We're going to write it as negative 1 over sine x times cosine x over sine x. Can I do that? And what can you say about 1 over sine? 1 over sine is cosecant, and the other one is cotangent. So what we have found is that the derivative of cosecant is negative cosecant cotangent, right? So we have found that the derivative of cosecant is negative cosecant x cotangent x. Let's call this formula 3, right? You have to memorize this as well. 4, if you can find the derivative of secant in a similar way. And what would that be? Secant x tangent x with a positive sign. Okay, now let's look at another example. How would you find the derivative of cotangent of x? Well, this is the derivative of what? Cosine x over sine x. Oops. And this is equal to, now I have to apply the quotient rule, so let's apply that. I have to square the denominator, right? And then in the numerator, I take the difference of two terms. What's the first term? It's the denominator, right? Multiplied by what? Multiplied by the derivative of the numerator, which is what? Derivative of cosine is negative sine x. And then minus, I have to have the numerator first, and then I have to take the derivative of the denominator. What's the derivative of the denominator? Cosine x. And then what I get is negative sine squared x, negative cosine squared x, all over sine squared x. What should I do from here? Was that separate into two fractions? Is that what you're saying? Yes. Yeah, you could, but instead of doing that, it's much better to do what? Well, I mean, that's a good guess, but there is an what can I do? What else can I do? Everybody realizes that the top is actually negative 1. Why? Yeah, it is negative sine squared x plus cosine squared x over sine squared x, which is, we know that sine squared plus cosine squared is 1. So I get this. And that is equal to what? Yeah, 1 over sine is cosecant, so this would be cosecant squared of x. Alright, so what is our formula number 5? We found that the derivative of cotangent of x is negative cosecant squared of x. And what would be 6? Do you have a guess for the derivative of tangent? Yeah, very good. So this would be secant squared of x. Okay, so those are the derivatives of the 6 trig functions. Okay. Any questions? You have to memorize all 6 of the derivative formulas. Is everyone okay with that? Everybody's okay with that? Alright, so what I want to do now is go over some of the exercises from section 2.4 where we are going to use these formulas. Before I do these examples or exercises, there is one more thing that I have to talk about, which is the following. Some notations here. So suppose that f is a function. So let y equals to f of x. So f of x is a function. Now, if we write f to the 0 of x, it simply means 0 within parentheses. This notation is used for just f of x. Okay, so this means just f of x. Now, if I have f to the 1 in parentheses of x, it simply means the derivative of the function f. Right? And if I use 2 here, what does that mean? It's the f double prime of x. What is the meaning of f double prime of x? It is the derivative of the derivative function, right? Derivative of the derivative function. And we can continue this way. We can say that this is going to be what? F triple prime of x, and that's the derivative of the second derivative, right? So before you can compute the third derivative, you have to find the second derivative. And usually then, if I have f to the 4 of x, triple prime, and then are you going to use 4 primes like that? No, we don't use that anymore. So we just say f to the 4 of x, that's the fourth derivative, and that's the derivative of the third order derivative. So basically we have the first order derivative is just the derivative. Second order derivative means it's the derivative of the derivative. Third order derivative is the derivative of the second order derivative. Fourth order derivative is the derivative of the third order derivative. And you can continue in this way. Fifth order, 99th order derivative of a function. And in this course, you will be only asked to find the up to second derivative. When you go to Calculus 3, you will see that you need to know in some problems the derivatives of all orders. Okay, and so you have to know what's the 50th order derivative, for example. There is another notation that is used for this derivatives. First of all, remember we are using y to denote the function f, right? So we can use dy dx for the derivative, right? We can use dy dx instead of just f prime, right? That's another notation for the derivative. How do we write the second derivative in this notation? The way we write it is the following. We take d2y. It means d means derivative, second derivative of y, and with respect to x, and we put a 2 there. So with respect to x twice. That's how I read it. How would we denote the third order derivative in this notation? Yeah, d3y over dx3. Is that making sense? And we can continue in this way. Is everybody okay? Let's look at a few examples. I think in one of the homework problems that is due tonight, you have to find the second derivative. So let's look at the following. Let's say I have the function y to be x cubed minus x. What is the first order derivative y prime? 3x squared minus 1. I didn't tell you this, but the second derivative can also be denoted by y double prime. which is what? 6x. Okay, what would be another notation for this? dy dx, or we can also say d2y dx, d2 for the second derivative. Is everybody okay with that? Is everyone okay with that? Let's try to do another example. Does anyone know which problem, the problem that is due today on finding the second derivative? Does anyone have that problem? You have that problem? I mean, do you have it in front of you? Can I see that? Okay. Can you look it up right now? Yeah, go ahead. Let me do that problem as an example. You got it? Okay, go ahead.
X squared over 9 plus 8x.
X squared over 9 plus 8x?
Yeah.
Okay, and is there a name for it?
F of x.
F of x. Okay, so let's say you have this function and you want to find the second derivative. So how would I find the second derivative? Well, another notation that I didn't tell you about is that the derivative of f with respect to x, right? This is a notation for the derivative. So that's the same as f prime of x. And how would I find the derivative in this case? Quotient rule. So what do I do? Square the bottom. You take the difference in the numerator of two terms. You have the denominator here, and then you take the derivative of the numerator here, numerator, and the derivative of the denominator. What's the derivative of the numerator? 2x, and what do I get here? 8 is the derivative of the denominator. But we need to simplify this. So what is that? 9 times 2, that is 18x, minus 16. Why do I say minus? Plus 16x squared minus 8x squared, right? Divided by 9 plus 8x squared. So what is that? I guess we have 8x squared plus 18x over 9 plus 8x squared. So that's the first derivative. Okay, now how do I find the second derivative? The second derivative, d2f over dx2, that's f double prime of x. What is that? Well, we still have to apply what? Yeah. So I have 9 plus 8x to the what? 4. Here I will write the denominator 9 plus 8x squared multiplied by what? The derivative of the numerator is what? 16x plus 18. Very good. And then I have 8x squared plus 18x, and I have to multiply by the derivative of the denominator. So what's the derivative of the denominator? What's that? The derivative of 9 plus 8x squared, right? So imagine this is just x, right? So you get 2 times this to the 1. So 2 times 9 plus 8x to the 1, and multiplied by what? Multiplied by the derivative of 9 plus 8x, which is 8. Is everybody okay with that? Okay. So what do we get? How would you simplify this? Well, you just multiply out everything. However, it can save you a little bit of time if you factor out whatever you can first. So notice that we can factor out in the numerator 9 plus 8x. So if I factor that out, what am I left with? 9 plus 8x times 16x plus 18, right? Minus 16 times 8x squared plus 18x, right? Is that right? No, but I have x squared. One of them I have 8x squared plus 18x, right? The other one I have... Yeah.
9 plus 8x times 16x plus 18.
You are talking about right here? You're asking to factor out this one as well?
9 plus 8x times 2.
9 plus 8x times 2, yeah, but here you have x squared. Right? Oh, I see what you mean, sorry. I am comparing it with this one. Yes, you're right. What he is saying is that 16x, so that's very good. The 16x plus 8 that you have there, what is that? It's twice 9 plus 8x. However, you can still just factor out what? You can still just factor out 9 plus 8x. Yeah, because you don't have a 9 plus 8x to the 2 here, right? You have to have the, whatever you're factoring out, you must have it in both terms. So even if I can write it as 9 plus 8x times 2, this would be 2 times 9 plus 8x cubed, right? But I still have only 9 plus 8x here. This one I cannot write as 9 plus 8x. So I can still only factor out 9 plus 8x. So that's a good suggestion, but you can still only factor out 9 plus 8x. Okay, so what can we do now? Well, we can cancel out this with what? What should I get here? Cube. And what do I have to do inside the brackets? Yeah, you have to multiply out everything inside the brackets, and then whatever you get, that would be the answer, okay?